And we are back again with LU decomposition using Gaussian elimination method. So let's simplify. Solve the matrix A, X, and then B using the LU decomposition with Gaussian elimination method. So from the question, we know that the matrix here is going to be A, and then we have the X portion, and then we have the B portion. So you have matrix A, X being equal to B. What we are supposed to do here is to decompose A into LU. So we have been given A. What we are going to do is decompose it, that is break it down into L and U. So to break A down into L and U, we are going to say that when we break A down into L and U, A is going to be equal to L times U. Alright, so the L portion is the lower triangular matrix and the U portion is the upper triangular matrix. So when we find the product of these, it's supposed to give us the A back. Now with the lower triangular matrix, what it means is that its trivial values are at the lower portion of the matrix. So if let's say if this A was a lower triangular matrix, you find the upper part being 0 and its trivial values being at the lower side, right? The same thing with the U, which is the upper triangular matrix, you will have its values at the upper side, that means upwards. Its trivial values will be on top and the lower side is going to be zeros. So now how do we convert this A into LU? So first we start with the U. So we say obtaining U. Now to obtain this U, we want to make it an upper triangular matrix, meaning the part we have as 2, 5 and 1 are supposed to be zeros to make it an upper triangular matrix. So we are going to perform the row operations on this matrix A in order to make it a U, that is an upper triangular matrix. So we start with the portion that has the 2 and make that row 0. So we make the 2 portion 0 and we alter the row itself. So how do we make the 2 0? When we take the 2 minus 2 times R1, which is 1, we are going to get 0 at the 2 portion. That's on the new row 2. We are not going to do it for just the 2. We are going to do it for all the values on that row. So we take the 3 also. 3 minus 2 times 2. What will we get? Negative 1. You put it there. Then you take 2 minus 2 times negative 1. What will you get? 4. And you put the 4 also there. So now you can see that we have our 2 portion being what? Being 0. So when you are done, you realize that we are using R1 as our pivot because we are on the first column. Now we move to the third row. So on the third row too, we want to make the 5 0. So how do we make the 5 0? We are still on the first column, so we are still using the 1 as our pivot. So when I take 5 minus 5 times 1, I can make that 5 portion 0. So you can see R3 minus 5 times R1. I'm going to get this 5 here to be 0. Then I'll take the negative 9. Now, if I take 1 minus 5 times negative 1, I am going to get negative 9 down here. And again, if I take 4 times 5 minus negative 1, I'm also going to get another 9 here. So you can see that it's affecting everything on the row, not just the 5, even though it is the 5 we want to make it 0. So now we have these two portions being 0. How do we make this negative 9 here 0 as well? So again, if you take this negative 9 minus 9 times this R2, which is negative 1, we can make this negative 9 also 0. So what is happening here is that we want to make this negative 9 0, and we are on the second column. So on the second column, you make the second row the pivot of your row operations. That is why we are using the R2 as our pivot, which is negative 1. So negative 9 minus 9 times negative 1 will make this negative 9 portion 0. Then we come here and take 9 minus 9 times 4. That will give us here to be negative 27. So now you can see that we have achieved our U, which is our upper triangular matrix, having the lower portion being what? Being zeros. So now we can go ahead and look for our L since we have U. So we know that L is a lower triangular matrix, meaning its lower part contains its trivial values and the upper part are the zeros. So you can have the ones running down this way. And from there, how do we get the remaining values? So we come back to where we said obtaining U. What was the exact coefficient of R1? We had 2. Neglect the negative sign. So you put the 2 over there. Then you come to the next one. What was the exact coefficient of R1? We take the 5. Neglect the negative sign. Then we come here to the last part. What was the exact coefficient of R2? We take the 9 and neglect the negative sign. So we put the values in there and then we obtain our L to be 100,210,591. Now that we have our L and then our U, remember, we are not finding L and U. We are looking for the value of X. To find X, there are some formulas we must go by. So the formulas are, we know the first one already, AX equals B. Since we know that A is equal to LU, then we can say LUX equals B. Now, if we make UX equals Y, then we can finally say LY equals B. Now, we know L and we know B, but we don't know Y. So if you're able to find Y, and since we know U, then it means we can find the value of X. So let's start with LY equals B. So since we know L and we know B from the question, we can find the values of Y using the forward substitution. So with the forward substitution, what it means is that we are starting to find our variables from the top, so forward, and then back substitution is that we are finding our values from the bottom, right? So from the top, we can see clearly that y1 is equal to 1. So now let's solve it manually. So using forward substitution, we can know that y1 is equal to 1. And then we can say here that 2y1 plus y2 is equal to negative 1. Since we know y1, we put y1 into the equation and then we find y2 to be negative 3. That is negative 2 minus 1, which is negative 3. Then we move to the next row. We have 5y1 plus 9y2 plus y3 equals 2. We make y3 the subject, and since we already know the values for y1 and then y2, we put them into the equation and we find y3 to be 24. Remember, we are not done yet. We are supposed to find x, not y. Since we started from the bottom, ly equals b, now we can use the next formula, which is ux equals y. Now that we know y and we also know u, it means finally we can calculate for what x is. So let's use ux equals y. Since we know u to be 1, 2, negative 1, 0, negative 1, 4, 0, 0, negative 27, we can now find x1, x2, and x3 since we know y. So for this one, we are going to use the back substitution because it is easier to find the value of x3 than it is to find the value of x1. You know, this side are all zeros. So to find x3, we are going to say using back substitution, negative 27 x3 equals 24. And clearly we can find the value of x3 to negative 8 over 9. Then we move to the next, we level up to the next row, which is negative x2 plus 4x3 equals negative 3. We make x2 the subject. We input the value for x3, and then we find x2 to be negative 5 on 9. Now we go to our final row, which is x1 plus 2x2 minus x3 equals 1. Since we know the values for x2 and x3, we make x1 the subject, put the values for x2 and x3 into the equation, and then we find x1 to be 11 on 9. Alright friends, so that's it for this video. If you have any questions, be sure to leave them in the comment section. I'll be willing to reply them. Don't forget to like and subscribe. Until next time, Apatia.